Hello everyone. I would like to introduce my time series observation of marine snow and its related chemistry. The global warming caused by increase of atmospheric CO2 is one of worldwide great concerns, and the ocean plays an important role in the control of atmospheric CO2. One of ocean's CO2 uptake mechanism is the biological carbon pump. For better understanding the biological carbon pump precisely, it is quantified how much carbon is assimilated in the surface sunlit euphotic zone, how much carbon is exported from the surface euphotic zone or the surface mixed layer, how much carbon is transported to the deep or how carbon attenuates with depth, and how much carbon is buried in the seafloor sediment. As satellite data shows, the biological carbon pump has seasonal and annual variability. Thus, time series observation is strongly requested for the study of the biological carbon pump. Sediment trap is a settling particles or marine snow collector. Since time series sediment trap was developed in middle 1980s, time series sediment trap observation has been one of center players of the study of the biological carbon pump. By deploying time series sediment traps at several depths, vertical attenuation and sinking velocity of marine snow can be quantified. By conducting time series sediment trap observation for multiple years, seasonal and interannual variability in marine snow can be quantified. This figure shows there are temporal variabilities in dissolved silicate SiOH4 concentration at 50 meter line graph observed by automatic water sampling system and biogenic opal flux at 200 meter bar graphs observed by sediment trap. It can be seen that quickly after dissolved silicate concentration decreased in late June, biogenic opal flux increased in early July. By deploying automatic water sampling system and time series sediment trap simultaneously, it can be revealed how fast assimilated nutrient is exported to the ocean interior. Time series sediment trap observation can also detect unexpected events. When the Fukushima Daiichi nuclear power plant accident took place after the great earthquake and tsunami in March 2011, time series sediment traps had been deployed at about 500 meter and 5,000 meter of our time series stations K2, which is about 2,000 km distant from the power plant, and station S1, which is about 1,000 km distant from the power plant. In addition, we started time series of sediment trap observation at 500 meter and 1,000 meter of station F1, about 100 km southeastward of the nuclear power plant in July 2011, 4 months after the accident. At 500 meter of station K2, the power plant derived radio cesium 134 was detected at first from marine snow collected between 25th March and 6 April. At about 5,000 meters of station K2, radio cesium 134 was detected at first time from marine snow collected between April 6 and 18th April, one collecting cup after the cup of 500 meters. Interestingly, radio cesium was detected at the same timing at station S1. Thus, it was revealed that the radionuclide emitted from the nuclear power plant arrived at 5,000 meters of stations K2 and S1 only about 1 month after the accident. Based on the numerical simulation, it was suspected that radiologically contaminated aeolian dust was transported to these distant stations rather than contaminated water. At station F1, radio-cesium flux was one order higher than that at station K2 and S1. Radio-cesium flux was high in 2011 and tended to decrease as time proceeds. Radio-cesium concentration of seawater also decreased as time proceeds, and in mid-2012, its concentration was almost same level of that before the accident. However, particulate radiocesium-134 was still detected even in 2015, as shown in these figures. And peaks of radiocesium flux appeared in autumn and winter when typhoon and low pressure passed near the Fukushima area. In general, radiocesium flux at 1000 meter lower panel were higher than that at 500 meter upper panel. Major component of marine snow collected at station F1 was lithogenic materials. Based on these observations, it was suspected that radiologically contaminated coastal seafloor sediment was resuspended, especially when sea condition was rough, and transported laterally to station F1. Left figure shows underwater profiling buoy system. Although time series sediment trap observation has contributed to the study of the biological carbon pump, it is very difficult to observe the biological carbon pump in the upper twilight zone and impossible to observe seasonal variability in primary productivity. Recently, my colleague has deployed the underwater profiling buoy system and observed seasonal variability in physical oceanography and dissolved oxygen, chlorophyll A, and index of primary productivity. Owing to this technology, it has become possible to observe time-series vertical profiles of physical oceanography and dissolved oxygen and subsurface chlorophyll A maximum in the upper layer. Finally, it has been challenged to observe marine snow optically. In this century, drifting buoy such as Argo float has become very popular and one of center players for oceanography. Bio-Argo float have chemical sensors such as dissolved oxygen sensor, fluorometer, and nitrate sensor. In addition to this, backscatter meter is in several cases installed on Bio-Argo float, and time series vertical profile of underwater particle concentration is observed successfully. In order to study the biological carbon pump, optical sensors such as backscatter meter and underwater video camera installed on the mooring system might be useful and helpful. As concluding remarks, it is suggested that the scientific target of ocean-side mooring observation is to monitor the change in the biological carbon pump caused by multiple stressors such as ocean warming, acidification, and deoxygenation, and to project its future change and feedback to atmosphere. Underwater profiling buoy system is recommended as a useful mooring system for the study of the biological carbon pump. As sensors, backscatter meter and pH and dissolved oxygen sensors are recommended as standard sensors for this purpose. That's it. Thank you very much for your kind attention.